So it's hard to be last because I'm the one keeping you from dinner and the reception and all, but thank you all for coming. And hopefully it's going to be worth it, since I'm going to help you save some money. Okay. So in the last year in Sygnia, the company I work for, we've got the task to reduce our cloud spend, and we managed to do it by 50%, which was quite impressive. And so I took all of the insights of the last year of reducing our bill and put it in a session, and I want to share it all with you today. So let's start. So the first, I want to start by asking, why should we even save this money? And this sounds a little bit trivial, but I want to stress out a few points here. So I talked to some of the founders. Some of them spend millions of dollars per month on AWS. Some of them, the DoorDash costs are higher currently because they're just starting, and that's okay. But actually, AWS bills and cloud bills in general have this property when they always keep growing, which is fine, but this is something to note of. And then saving early will pay off with interest. So it's really something to think about when starting a company, whether you're small or whether you're big. And obviously, money. So that's the reason the companies exist. And other than increasing company margins, it can also affect your business strategy. So what I mean by that is think about, are you able to sell to organizations that are, for example, small businesses? Can you do free trials? If doing a free trial, if having a trial account in your product costs you a lot of money, then it might be not cost effective to do that. So saving money on the cloud can actually affect business strategy. So I'm going to talk a little bit about FinOps and how to do proper FinOps processes in your company, and then we're going to do a drill down into AWS specific services. I'm going to share some tips and tricks that not everyone knows about how to save money in services. So first of all, let's start with FinOps. So to have a proper FinOps process in your company, the first and most important thing is tagging everything. You need to tag every resource that you create by every dimension that is relevant for your organization. It can be environments, tenants, teams, whatever language that you use in your organization. Now, it's really important to get this right, because if not everything is tagged correctly, you won't have any visibility and you won't be able to gain any insights. So I propose two ways that we in Sygnia are implementing to make sure that tagging is done correctly. The first one is automation, and the second one is validation. So for automating, what you can do is something like that. So, and this is a very, very common pattern that you can see, for example, in this case, in Terraform. So what you can do is have a private Terraform module that standardize and formats the tags that you want to have in every resource in your cloud. So it's a really simple module. All it does is basically has a few required fields, which are your tags, and it can format them if you want, and anything like that. Then every module that you use in Terraform, you can just add tags and use your module instead of writing them over and over again. So every developer that writes any Terraform module can have the proper labels without even knowing what the proper labels are to avoid mistakes. Now, you can still forget to tag things. Maybe they're not created through Terraform or any other reason. So you also need to have some kind of validation on your tagging. What we do is we use AWS Config, which is a nice AWS service where you can set up rules that you want AWS to enforce. So, for example, we're looking for every AWS resource that doesn't have specific tags. And those tags are the tags that you can write in your private Terraform module. So you can actually configure that AWS config rule through Terraform and make sure everything is standardized. So for example, here you can see a Slack notification from AWS config about a network interface that doesn't have all of the required tags. So this is a nice way to find zombie resources or things that are not tagged correctly, and we'll talk about it more in the next slides. So this is about tagging. After everything is tagged correctly, you want to have some kind of a visibility into your AWS bill. So you really want to use some kind of a system You can use AWS Cost Explorer, which is built in AWS. You can use FinOps, which is actually right over there in the booths, and they're great. And you can actually use Datadog, which we learned about this morning. And then you want to start looking into your data, performing visualizations, either per tenant, per service, per team, again, whatever makes sense in your organization. Once you have a system and you can see the data, you want to have some kind of a continuous tracking. So what you can do is have automated reports either for your mail, Slack, have alerts on changes in your spend, and so on. So we tagged everything. We can look at the bill and see what are the spend factors. We track them over time. And then lastly, we want to gain some insights. So we want to identify the top spend factors, the things that if we will improve will save us the most money. We want to understand the true cost of every service, and I'll touch about this term in a second. But eventually, understanding pricing in AWS is a very complicated task. Some of the services have quite complicated pricing. So for example, it's not only priced by API calls, it also has storage, encryption, and anything like that. And then you want to drill down into the services themselves and try to understand if you can optimize them. And before you start any journey for saving money in the cloud, you want to make sure you understand 3 things for your organization. The first one is, what is your goal? Meaning, what do you want to do? Do you want to reach a specific monthly bill? You want to have a percentage of savings like we did? Or maybe you want to have, you have a goal per tenant. You want a tenant to cost not more than $1,000 per month. After you have your goal, you need to understand what are the constraints for this process. What can and can't be done? Can you hurt the developer experience? Can you change the SLA? Can you make application changes? Probably the answer for some of those questions are no. So you want to understand what can you do, what are the rules of this game of optimizing your cloud. For example, making developer machines use spot instances might reduce the cost, but might shut down their machine unexpectedly. So this is like a trade-off that you need to understand if your organization can tolerate. And lastly, and this is really important, and most of the companies miss that, is what is your business unit cost? Now, what is a business unit cost? It's basically a metric that you normalize your cloud spend by this metric. So for example, think of, you wake up one day, you look at your bill, and you see that the bill is twice as much as the previous month. But then you understand that your company had 3 times more customers in this month relatively to the previous month. So did you spend more money? Did you actually save money? So you need to have some kind of metric, and sometimes number of users, number of tenants. This is a good metric to have to understand where your bill is going, and actually communicate that to other parts in your organization, such as finance, your boss, the VP R&D, whatever it is that can walk into a room and ask, why is the bill so high? Okay, so this was FinOps processes in general, and now we're gonna go into the interesting stuff, the deep technical dive into specific AWS services. And I chose a bunch of AWS services that we use and we have some insights about, and are actually probably very popular and appear in your top cloud spend report. Now, understanding AWS services is extremely important for you to be able to effectively save money in the cloud. However, it's not necessarily means that it will help you, because these things can still happen, but it's a good start. Yeah, it's a good one. Okay. So the first one is EC2. This is probably the top spend in most of the accounts for good reasons. And we have some interesting things we can do with EC2. So the first one is instance type and utilizations, which is the most important thing. Basically, choosing the right machines and making sure they are utilized correctly. One cool thing you can do is actually set up a Datadog monitor to make sure to know about servers that are not utilized correctly. So for example, here is a real monitor that popped up in our production account. So we saw a production processing server that is not utilized, and now we can maybe have the decision to make it smaller, change the configuration, or anything like that. So Datadog can really help us here as well. The next thing is Graviton 2. For those of you who don't know, this is AWS ARM-based chip. This is worth like a session of its own because it's a huge revolution. But for our case, it can using instances with Graviton 2 can actually give you 15% price reduction and make your application 20% faster, which is never it never works like this. Usually, it's some kind of a trade-off. So when we saw this publication from AWS, these numbers, we were like kind of skeptical. And the next thing we did was going to our RDS instance and change the instance type from M6 to M6G. It's just a Graviton 2 instance for RDS. We actually saw 15% price reduction and 20% more transaction per minute on our RDS. So this was very, very impressive. And what's nice here is that it might be hard to compile your application to run on ARM, although it can be a really good reduction if you do so. But if you're using managed services like RDS, Elasticache, and OpenSearch and more, you can just go hit one button and get a 15% price reduction and get a faster application. So that's like something you can do tomorrow morning. There's no there's no cons here, basically. So I really recommend you doing this. So Devons is another big thing. So basically, when you're looking at your cloud spend, a lot of companies are only looking at production, but this is actually you really want to look at all of your environments. So Devs is interesting because it has like different properties from production. So for example, you can use things like T3 or Spot instances, which are very, very, very cheap and has some different trade-offs. Or you can do some kind of a shutdown policy. So for example, shutting down Devons or test machines on weekends or nights or anything that works for your organization. And this can be like a 50% really easy reduction on Devons. So make sure you do that. Another cool invention from AWS is GP3 disks. For those of you who don't know, this is the next evolution of AWS SSDs after GP2, which was for the main disk for a long time. And this is, again, one of those weird AWS magics where it's 20% cheaper and actually has higher IOPS and throughput in some of the cases. So this is really, really interesting. And again, you can convert current disks with a click of a button. Or and what I really recommend is, again, going back to your Terraform and making sure that all of your modules are creating disks with GP3 as default. Because, again, they're 20% cheaper. And lastly, and I think this is my most important takeaway from this EC2 slide, is staying up to date with AWS news. As you can see, there are AWS announcements that can really affect your bill if you know how to use them correctly. So I usually read this in the morning with my coffee, which might be a little bit weird. But then you can find out things like these. So these are just announcements from the last couple of months or a year. And these are new instance types that were announced that, again, so for example, you can see C6A, which has a 10% lower cost than the previous generation or the comparable x86 versions. So AWS News every week is announcing something that can reduce your cost. So I really recommend following up on that. So I mentioned true cost in AWS and the fact that if you look at services, the cost of the service is going to be complicated because it's going to involve more things than just the service itself. For example, networking. So networking is a very big cloud spend factor, and it usually appears with a big spend, but it's hard sometimes to understand what types of services use these networks, this networking usage. So yeah, this is what you really want to do is differentiate between a couple of different networking usage types. So the first thing is outbound versus inbound. Usually AWS really likes inbound, give us all your data. They don't like you to get it out of your VPC. So outbound, really look out for outbound. It's extremely expensive in AWS, and I'll share a way to minimize this in a second. thing to look out for is cross-region or cross-availability zone. You're paying extra fees on that as well. And funny story on that in the next slide. And VPC endpoints or private links, which is actually a way for you to avoid that outbound networking, can be really helpful, but has some hurtful pitfalls as well. I want to give one example of Elasticsearch. We run a lot of Elasticsearch clusters. And Elasticsearch is great and recommends by best practice to run it on multiple availability zones. And that's exactly what we do. But it took us a long time to understand that even in managed Elasticsearch service, there is a configuration that is not on by default and affects networking pricing dramatically. So basically, this is a screenshot of a true PR that we did. It's just 2 lines of code, which basically enables compression between data nodes of Elasticsearch. So Elasticsearch will move a lot of data to sync data nodes. And so we turn on LZ4 compression, which is a really nice compression because it has minimal CPU hit. And then after those 2 lines of code and a deploy, what we saw is a reduction of more than 50% in network between those data nodes. And what's nice in AWS is everything is linear in terms of the pricing. So 50% reduction of network equals exactly 50% reduction in price. So this was like a nice example of understanding the true cost of Elasticsearch, which it was in our case a lot more than just servers and storage. It has this network factor as well. And because we ran in cross availability zones, we paid a lot of money for it. So this was a really nice save. And this is relevant for not only Elasticsearch, right? If you're using Kafka, Kinesis, every distributed system that moves a lot of data from regions or availability zones. S3, again, one of the most popular and probably one of the big spenders in most of the accounts. So first of all, I want to stress out the difference in price for S3 and SSD, which is, as you see, $23 per month per terabyte, opposed to 800, which is a very high difference. Not talking about high availability and backups and things like that S3 is doing much better. So really prefer S3 for non-classic file system use cases. And the most important part, which a lot of companies miss, is have your life cycles on your S3 buckets. So in AWS, you can move data from standard S3 tier to lower tiers if you can handle some trade-off. For example, latency to reach that data. It's a classic use case for example, if you do backups and things like that. And there are a lot of different tiers with different types of trade-offs, so you can choose whatever works for you. But I wanted to add this graph of how much does it cost to store 10 terabytes of storage in AWS in different storage tiers. So the largest one is SSD, then this is S3 standard, infrequent access, Glacier instant retrieval, and Glacier Deep, which is the lowest tier possible in AWS. And this is actually the cost of, if you don't know, the cost of a slice of pizza here in New York. It's 99 cents per terabyte per month, which is really impressive. You can save a ton of data for a very small amount of money. So have your life cycles on your buckets. And again, going back to automation through Terraform, have your S3 module require some kind of a life cycle. Even if you don't need the life cycle, just have an empty life cycle, but have the developers confront that question when they have that model. Okay, moving on to SQS. So SQS is one of those services that you really need to understand. It's really hard to understand its pricing model. It's really complicated because it has a lot of different parts to it. So for example, one thing is that it works in billable units. So you only pay for each 64K of message that you're sending, and you can send more than that. So if you send 65K, you're actually paying for 2 billable units. And this, if you're using this in high throughput, this means that if you're not optimizing your requests for specific sizes, you end up spending a lot of money on this one. Another thing is the transfer cost. So again, Networking comes back here. So if you're going outbound or if you're going cross AZ or cross region, you're going to pay for that as well. So what we did in Sygnia is actually wrote a model, which we might be open sourcing soon, that does smart batching that does not exist in any of the AWS native libraries, which try to optimize the message size for performance and pricing at the same time. So as you can see, there is a maximum message size in SQS of 256K, and we try to be somewhere in those 64K split, so we don't pay extra, but also have the maximum message size, so we minimize calls for SQS. So this is like quite a complicated code. We might be open sourcing it soon, so you can all use it. Another thing here, when I touched before, one second, is compression. If you're using things like JSON, which are just text, compression can be really nice here. Again, LZ4, which has very low CPU heat, can get you for 10x price reduction for your SQS messages. Having compression and smart batching at the same time is quite complicated, but it's also it's possible as well. But you need to understand what's best for you. Okay, cross AZ endpoints. This is a fun anecdote that I wanted to share with you. So as I said before, when you're accessing any AWS service, you need to you have two ways of communicating it. Either going through the internet and basically paying for that outbound network, or use AWS endpoints, which basically are those blue shapes here. These are endpoints that are connected to your private VPC, and you can access the service directly from there and not pay for the outbound network. Now, if your service is running on a few availability zones, which might make sense, AWS is nice enough to give you an endpoint in each availability zone. So if you're running on zone 3, you can use an endpoint and access the SQS in this case. At least that's what we thought. What we discovered is very, very, very high cross availability zone charge in our bill at the end of the month. And when we looked at the server, we actually we looked at that endpoint. We did an NS lookup, and surprisingly, we got 3 IPs back on a server that was running on a specific availability zone, let's say availability zone A. So that actually means that the real diagram should look something like that. So all of those red lines are communications that cost you a lot of money. So if you're running on AZ3, you're doing a round robin between all of those 3 endpoints. One of those endpoints is free for you to use because it's the same availability zone, but the other 2, you're paying a lot of money for it. If your application is running in a few instances in a few availability zones, you probably don't need that sort of high availability in the endpoint because your application is already highly available, because you can run it on different availability zones if one availability zone goes down. So this was an interesting find. What we did is actually 2 things at once. First of all, we contacted AWS and tried to understand why is this the default behavior and is this supposed to be like that. And then we also did a fix in our code. So we wrote that function, which basically, when our application starts, it understands which availability zone does it run in, and then only uses that specific endpoint and not using the main endpoint DNS name. So we can only write for the correct endpoint in each availability zone. We deployed that. We saw actually a 66 price reduction in our cross availability zone charges, which was very, very nice. We continued talking with AWS about this issue, and after about a week, reading the AWS news blog, we saw this. We're not sure if it's related to us or not, but they actually reduced the price to 0 for cross availability zone in private link use cases. So that was really nice, although we had to revert our code and just delete it. And this is relevant for SQS as well for other services that you're accessing using private endpoints in multiple availability zones. We can't talk about price reduction without talking about Kubernetes, which was really present in this conference as well. So first of all, if you get Kubernetes right, you are running multiple applications on a shared infrastructure, which is a price reduction on its own. But you can do even more complicated things like horizontal pod auto-scaling that allows you to either avoid over-provisioning and handle peaks at the same time. Specifically, we at Sygnia, we use Keda, which is an open source alternative to the default HPA in Kubernetes. And it has a few really, really nice features, but it has one killer feature, which is the option to scale down to 0, which surprisingly does not exist in the default HPA. This can look like a small difference, but if you have hundreds of microservices, having the option to scale down to 0 and not to 1 can be a really, really huge price reduction. Another thing is vertical pod auto-scaling or right-sizing, which means setting your requests and limits for your pods correctly, which is quite an impossible mission. There are a few companies tackling this, even companies here in the booths in Dash. And I do want to mention that combining horizontal and vertical pod auto-scaling is currently in sort of like an experimental beta. It's called multi-dimensional auto-scaling, and it's quite complicated. And it seems like the community haven't solved that issue perfectly yet, but I hope it will get there soon. Lastly, spot instances. So when we moved to Kubernetes at Sygnia, we made sure all of our services are stateless and scalable. And so 100% of our clusters are spot instances, which AWS markets as up to 90% price reduction. We didn't really believe that, but actually after we deployed everything, it was pretty much correct. We got 70, 80, and sometimes 90% reduction, which is really, really impressive. Yeah, and that's Keda. Some last few tips before I go, which are not specific for specific services in AWS. First one is saving plans and reserved instances. I really like this one because it's 0 application changes and 0 infrastructure changes and 0 deployments. It's just some clicks on the AWS console. It's not easy to get. You need to somehow predict and calculate your usage. You need to be able to commit to some of that usage. But if you can, let's say you can commit for using a specific instance type for a specific workload for a year or for 2 years, you can get price reductions for 40 or 50% just by committing this usage for AWS. So they know they get their money and you get your discount. So this is a really nice one. If you're not doing this and you have predictable workloads, you should really look into that because it's the easiest thing to do in terms of technical work that needs to be done. Zombie resources. So coming back to the tags issue I discussed in the beginning, almost every AWS account has some kind of zombie resources, which means resources that are not used anymore. So for example, old snapshots and detached volumes and things like that. What I recommend is using a really nice tool from AWS called Tag Editor. They didn't intend for this usage, but it works. What you can do in Tag Editor is actually have a reverse query. So you can, instead of tagging things, you can say, give me all of the AWS resources that are not tagged with specific labels. You take the labels that you decide for your organization, and basically everything that pops up in that query either needs to be tagged or needs to be deleted. So again, we discovered thousands of dollars that are just laying around in regions that we're no longer working, things the developer just left, and just mistakes in Terraform and things like that. So this is a nice thing to do quite often. You can even automate this process to alert you of zombie resources in your account. Lastly, and these are 2 points that, again, worth a session of its own, serverless is huge here. So things like Lambda, Aurora, and DynamoDB are becoming very popular. And if your application is using those databases or have some kind of non-continuous workload, which means you might want to do a query only in the night. You have some kind of an ETL which works only in the night, and then the database is not doing anything until the next day. Things like Aurora and DynamoDB and Lambda can really help you reduce cost instead of running, for example, a 24/7 RDS or anything like that. And cloud-native databases, which is another huge revolution. Things like Snowflake, where compute and storage are actually decoupled. So you can store as much data as you want, and you don't have to over-provision your RDS and just make it bigger and bigger and bigger just for it to hold the data that you have. You can store as much data as you want and then use specific resources depending on the query or depending on the amount of money that you want to spend on a specific question you want to ask. So that is the main insight that I wanted to share today with you. I just wanted to make a quick overview of how to do FinOps effectively in your company. So start by setting where do you want to go, what can and can't you do, and what is the business unit cost, meaning how do you explain your CFO why the bill got so much larger. Then have some kind of billing data visibility system, which requires you to tag everything and track it, and have alerts sent to your email or Slack or whatever is comfortable to you. Then gain really, really deep cloud provider understanding. Have those top spend in your bill and dive into the pricing page because you'll find surprising things over there. And then actually make your changes, either buy the reserved instances, make the changes in your Terraform, and do whatever you need to do and gain profit at the end. That's it. Thank you very much. I believe we have time for some questions.
Yes, we have time for questions. If you have questions to Yuval, please come to the mic.
There. I really love the future-proof nature of your recommended Datadog monitor on a server being too idle.
Yeah.
Were there any other monitors like that you found to be very useful?
Yeah. So there were a few monitors that we set up. I would say that it depends on your architecture because you really don't want them to have false positives. You want to have like a very sparse monitor that when it hits, you really want to do something. So we have idle servers. We have disks that are not utilized. So, for example, an RDS with a 2 terabyte disk that only uses 200 gigabytes or something like that. We have S3 sizes. So S3 buckets that are only getting larger over time, which means either there need to be some kind of a lifecycle or a deletion lifecycle or anything like that. So disks, S3, EC2s, and the rest will be a bit more complicated and depends on your use case.
Thank you.
Hey, so this is good. Thank you. So that example that you showed about making the code aware of the AZ that it's starting up in to look up the AZ specific endpoint.
Yeah.
It involves making the code aware of the infrastructure it's running in. I don't know if everybody follows that, but some of us are a little circumspect about making the code that much infrastructure aware. Did you explore any other possibilities where you could take that decision making outside of the code, but in your Terraform modules or something like that?
Yes, you're absolutely correct. I don't like the code that we added to our application because, as you said, it's not good to have that knowledge. I would say that when you get this technical with the AWS infrastructure, you sometimes don't have a choice. We've done it like a couple of times, either to have things that are more performant or in this case to save money. And I don't have anything to say, but I agree with you. And I'm really glad that AWS fixed that issue so we could remove that. Because again, AWS had made a constraint here that didn't allow you to not know about the underlying infrastructure if you want to save money. So, yeah.
Thank you. Yeah. The other question I had was general approach, asking about general approach. All your examples are what I would also consider common cases that people would face, but sometimes the cost comes not from this precise architecture, but say something like data model. A common example would be that RDS, you can save a lot of money by having provisioned instances, right? But AWS provides zero discounts on IOPS, and at least not to the average company, maybe to very large customers, not to us definitely. And in such cases, have you first encountered such cases where it would essentially involve re-architecting the data model that you have to maybe reduce the number of joins you are doing and things like that? So I'm not asking about a specific example, but did you encounter such situations where it went beyond your infrastructure architecture, and what approach you took?
Yes, first of all, for sure, I think the biggest changes that you can make require you to change your actual application or data model. If you can change your data model, that's like a huge game changer. It does require a lot of more work. I personally believe that like the organizations that I've been talking to do not necessarily have big FinOps team or big resources to put on these kinds of tasks. That's why I really encourage people to do things that are very light on the resources that they need to put in. It's easier to convince your organization to put that effort. It's easier it basically makes you save money better than making like a huge change. I would have pricing and like billing as a culture thing company, that when you're designing your next feature, have that in mind when you're designing the data model. I wouldn't necessarily change the data model just to do this unless it's number one priority for the company. So again, I really encourage people to have a look at, it's not lowest hanging fruits, but it's things that do not require things like downtime or huge projects or anything like that.
Thank you.
You mentioned using the horizontal pod autoscaler and the vertical pod autoscaler.
Yeah.
And that can introduce a lot of complexity, particularly with the vertical pod autoscaler, since it's changing the resource allocation on the pod, it can cause a restart of the pod.
Yeah.
So how do you prevent that from causing, for example, an outage or downtime in your application?
That's a great question. We're also facing that question as well at Sygnia. Basically, if you're at the point that you're using an autoscaler, you really have to make like you have other problems to tackle before that. So you really want to have your application to be able to handle graceful shutdowns, ungraceful shutdowns, be stateless and scalable. So you really want to make sure these things are in place before you use, especially before you use a vertical autoscaler, because you're correct, it really stops the current pod, then only starts another one. So make sure your pods can handle pretty much anything up to like electricity break, and only then use it. Horizontal pod autoscalers are a bit easier because they have like a more graceful shutdown policy, but these have the same problems as well. So I hope that answers your question. Thank you.
Hey, you mentioned you had a fun surprise at the end of the month. I wonder if you have any insights into rapid detection of something terrible happening with your cost, say a push that you...
Sorry, I couldn't hear it. Can you speak?
Is this better?
Yeah. Just speak louder, please.
Okay. So you mentioned you had a fun surprise at the end of the month. I wonder if you have any insights into rapid detection, say a push, which is causing like a huge increase in your spend.
Yeah, so I would split that answer for two. So there are huge differences in spend. So for example, suddenly you're spending thousands of dollars more than what you do for like a mistake or like a Lambda explosion, if you heard about that, or things like that. These are things that I would do in AWS natively. They have guards that you can set up specific budgets or limits for things to not, go over their limit. I do think that for smaller changes in spend, it's really harder to catch at a specific month. It's also harder to change at the end of the month. It sometimes takes a few months to understand that there is like a trend here, and not because the spend is always going to change. So I wouldn't necessarily have monitors on small changes every day, every month, because your workload changes and your pricing changes. But I would track it on a longer term. So I would put guards and limits to track it short term, and for the longer term, I would do it like differently. Not with monitors and automatic things. I would just analyze the span, try to understand trends and things like that. I think again, like the business unit cost plays a big role here. So if you have that, that really helps because, for example, one of the speakers here in Dashi works at Shopify. We just discussed yesterday over dinner Black Friday and Friday Monday, all of those peaks of workload where their spend is changing by hundreds of percent for a few days or for a month, and then comes back again. So I would take a look at your your metric that you're normalizing to, users, number of purchases, whatever that would be. Normalize your graph according to that, and then look for trends to avoid false positives. Okay, thank you very much.